Well, hello and welcome to this exercise on solving the exponential equations and also for finding expressions with common base. Uh, this is an IGCSE, GCSE type question, and as usual, it is an exercise on revision, not answer it at the same speed as you do in an exam situation. Now, here we go, and the first one says um, that 4 to the power 2x or exponent 2x is equal to 16. And the next one says 32 to the power raised to the power 2p minus 2 times a to the power p is equal to a half raised to the power 2p. And the third one says 3 to the power 3 minus x times 3 to the power 3x is equal to 1. And the fourth one, which is not an equation but an expression, says when y is equal to 3, evaluate y to the power minus a half plus y to the power half all to the power of 1/2. Okay, now firstly, in order to get this to the same base, the left hand side and right hand side to the same base, I can see that 4 is 2 squared and then 16 is 2 to the power 4. Okay, so we then have for the first one that 4, which is 2 squared, raised to the power 2x is equal to 2 to the power 4, which is 16. And by the laws of indices, 2 times 2s will give us 2 to the power 4x is equal to 2 to the power 4. Now the left hand side and the right hand side have got the same base. So now we can equate the indices now. 4x is equal to 4 there. That's what we got there. If we now divide both sides by 4, we end up with x is equal to 1. Now to check, if x is 1, 2 times 1 is 2. Sorry, 2 times 1 is 2. And 4 squared is same as 16. So we're okay. Now, similarly, for the second one, 32 can be expressed as 2 to the power 5. 8 can be expressed as 2 to the power 3. And 1/2 can be expressed as 2 to the power minus 1. So for the second exercise, we have 2 to the power 5 raised to the power of 2p minus 2 times 2 to the power 3, which is 8, raised to the power of p, and all that is equal to 2 to the power minus 1 raised to the power of 2p. And because we are multiplying here, we can add the indices later at a later stage. Okay, so we then have 5 times 2p is 10p, and 5 times 2, sorry, 5 times minus 2 is minus 10. And of course, we got 3 times p is 3p, and then minus 1 times 2 give me minus 2p there. So for the left hand side, because we multiply, we can now add the indices. Now because they got a common base of 2 there, 2 there, and 2 there. For the left hand side, we can add the indices and then equate it to the indices on the right hand side because they got a common base of 2. So we now have that 10p minus 10 plus 3p is equal to minus 2p. When we collect like terms, add 2p to both sides and add 10 to both sides, we end up with 15p is equal to 10. If we now divide both sides by 15, we end up with p is equal to 10 over 15. And if we then simplify it further, we end up with p is equal to 2 over 3. That's the value of p. Now, for the third one, we got 3 into 3 minus x, sorry, 3 raised to the power of 3 minus x, and then 3 raised to the power of 3x is equal to 1. Now, We know that a number raised to the power 0 will give us 1. So we're going to utilize that knowledge for solving the third one there. So we then have that 3 to 3 minus x times 3 raised to the 3 minus x times 3 raised to the power of 3x equal to 1. And that's the same as saying 3 raised to the power of 3 minus x times 3 raised to the power of 3x equal to 3 raised to the power of 0, because 3 raised to the power of 0 is 1. And because we've got a common base of 3, 3, and 3 there, and because we're multiplying there as well, we can add the indices there and equate that to 0. So we then have that 3 minus x, which comes from there, plus 3x, which comes from that one, is equal to 0, and the 0 comes from there. Don't forget, they got common base there of 3. So now when we expand the bracket and collect like terms and subtract 3 from both sides, we end up with 2x is equal to minus 3. So x is equal to minus 3 over 2. Now for the fourth one, which is not an equation but an expression, we have here that y to the power y to the power minus a half plus y to the power of a half, all raised to the power of 1/2. Now we can express y to the power of minus a half as 1 over y to the power of a half. So we do the inverse of that. So we then end up with this one here. 1 over y to the power of a half plus y to the power of a half, and everything in the bracket raised to the power of 1/2. Now this term here, which is y to the power of a half, can be expressed as y to the power of a half divided by 1. So the least common denominator of y to the power of a half and 1 is y to the power of a half. We then have that 1 plus y to the power of a half times y to the power of a half divided by y to the power of a half, because this one here, y to the power of a half times y to the power of a half divided by y to the power of a half, will give us the same as this one here, y to the power of a half. When you multiply y to the power of a half times y to the power of a half, and by the law of indices, we add half plus a half will give us 1. So we end up with 1 plus y to the power 1 divided by y to the power of a half, all raised to the power of 1/2 there. Okay. Now we are told that y is equal to 3. In which case, what we now have is y plus 3 divided by 3 to the power of a half, all raised to the power of a half, as we got here. So 1 plus 3, which is y, divided by y raised to the power of a half, all raised to the power of a half. Now 1 plus 3 is 4. So we have 4 divided by 3 to the power of a half, all raised to the power of a half. And 4 raised to the power of a half is 2, because the square root of 4 is 2. So that's 2 there. And by the law of indices, you're going to multiply this power here by this power there, which is a quarter. So we end up with 2 divided by 3 raised to the power of 1/4. And that gives us 2 divided by 1.316, which then gives us 1.52 to 3 significant figures there. Now, I hope all that made some sense. Please subscribe, and thank you for watching.